Hi, this is the word solutions to your straight line quiz from last week. At the end of the quiz, you would have received some feedback, so if there is a question that you got wrong, feel free to skip forward to that question, have a listen to it, make sure it makes sense to you, and obviously get in touch if there is anything that you're not sure about. This is also a good chance for you to make some additional notes. So this video will mainly focus on your perpendicular gradients and your altitudes, so if that is something you feel you need to work on, then feel free to take some of these questions and add them into your notes. So the first question, it gives you an equation of a line in your general form, and it's asking you to find the gradient of the line L, and L is perpendicular to that line. We've got our four options there, so you're going to have to start off by rearranging this general form. So there are several ways that you can leave the equation of a straight line. This is just one of them. The one that you'll be most familiar with will be y equals mx plus c. Now that's something that you use a lot at National 5, because if it's in the form y equals mx plus c, you can extract your gradient and your y-intercept. So we're going to manipulate this and get it into that form. So we've got a negative 3y. Best thing to deal with first is getting that to be a positive. So to turn that into a positive, we're going to add 3y onto both sides of this equation, and we'll get 2x minus 6 is equal to 3y. Now, because it's in the form y equals mx plus c, just to put everything in the order that we'd be most familiar with, I'm going to rewrite that as 3y equals 2x minus 6. From there, we want to get to y equals, we don't want 3y equals, so we're going to divide both sides by 3. So this gives us y on the left hand side. Now remember, when you're dividing by 3, you're dividing everything by 3. So 2x divided by 3 is just the same as 2/3 of x. Negative 6 divided by 3 gives us negative 2. So from that, we can extract our gradient, which is 2/3. And if the question asked us to, we could extract our y-intercept as well. So we're working with a gradient of 2/3. For a perpendicular gradient, you should be able to times your two gradients together to get -1. Now, make sure you're writing that statement out. It's always a good reminder when you see the word perpendicular to know that when you multiply your two gradients together, you're going to get -1. But the easiest way I think of thinking about this is to think of it as flipping the fraction, changing the sign. So if we've got positive 2/3, we're going to change the sign to a negative, and we're going to flip that fraction upside down to 3/2. So our perpendicular gradient is -3/2. Looking up at our options, that is option A. So for question 1, your answer should have been A. Moving on to question 2, we've got a very similar question again. So you're given an equation of a line in the general form, and you're asked about a perpendicular line, and you're finding A. So remember, this is in the form y equals mx plus c, so this is just another way of them asking you to find your gradient. So we're going to start off very similar to the last question by working through this equation here to get it into the form y equals mx plus c. This one's much nicer because we've already got a positive y. Not only that, it's a single y. So I'm going to have to take away 3x and take away 1 from both sides, and I end up with y equals -3x minus 1. So this is the equation of that line written in the form y equals mx plus c. So from there we can see that our gradient is -3, and if we were asked, our y-intercept would be 0, -1. So for perpendicular gradients, you would take your two gradients, multiply them together, and you would get -1. We've currently got that our gradient is -3. Now remember that -3 is the same as -3/1. Any number written by itself is that number over 1. So this time when we're thinking about flipping it upside down and changing the sign, our -3/1 is going to become a positive. Flip your 3 and 1 to become 1/3. So the value of A is 1/3. question 3 says if the points 3, 2, negative 1, 0 and 4k are collinear, we have to find the value of k. So for points to be collinear, you should find that these 2 points and these 2 points have the same gradient. Because they've got this point in common, that would make them collinear. Now that doesn't have to be the points that you choose. Some of you might decide to work with 3, 2 and 4k instead. It doesn't matter which pairs you pair off, as long as you're using one pair where you're going to get a definitive final number answer and one pair where you're going to have this unknown value of k. So I'm going to start off by finding the gradient of my known values. So I'm going to label them x and y, x and y. Remember, it doesn't matter which is coordinates 1, which is coordinates 2. I'm going to make these coordinates 2 purely because they're bigger and nicer numbers. They don't involve any negatives. So to find the gradient of that first point, I'm just going to call this M1 because our points aren't labelled with any letters. We are doing y2 minus y1 over x2 minus x1. Remember, y is over x's for gradient. So we've got y2, which is 2, take away y1, which is 0, over x2, which is 3, take away x1, which is negative 1. 2 take away 0 is 2, 3 take away negative 1. If you take away a negative, you add it on, so it gives us 4. Always simplify your gradients where you can. So the gradient of the first 2 points is a half. That therefore means that the gradient of the next 2 points is also going to be equal to a half. So the first thing we're going to have to do is come up with an expression for that gradient. So I'm going to call this M2. Referring back to my points, I've got x1 and y1 here. So I'm going to call these x and y and make these 2 and 2, just so that I don't have to have too much work in. So my gradient formula, I'm just going to look back to here to use it. We've got y2, which is k, take away y1, which is 0, over x2, which is 4, take away x1, which is negative 1. K take away 0 is k, 4 take away negative 1, we would add them together to get 5. So M2 is k over 5. Since they're collinear, we know that the gradient of our first part must be equal to the gradient of our second. So that means that a half is equal to k over 5. We're working through this to find the value of k. So to get rid of that 5 on the bottom, we're going to multiply through both sides by 5, and we would end up with k equals 5 over 2. You could also write that as 2.5, or you could write it as 2.5. Write it however you want, but that should be your final answer. For question 4, we're given the equation of 2 different lines, and we're asked to assess whether they're parallel lines, perpendicular lines, or neither. So we've got y equals negative 5x plus 2. That's already in the form y equals mx plus c. So from this one, we can see that our gradient is negative 5. To assess if they're parallel, perpendicular, or neither, we're going to be looking at their gradients. So that's us found our first gradient, M1. The next equation, we've got this 2x minus 10y equals 15. That's not as straightforward because it's not in the form y equals mx plus c. So much like questions 1 and 2, we're going to have to manipulate that. Now to do that, I'm going to start off by adding 10y to both sides. And the reason that I'm doing that is so that I've at least got a positive y. That gives me 2x equals 15 plus 10y. I'm then going to subtract 15 from both sides because I'm aiming to get that y on its own. So I've got 2x minus 15 equals 10y. I'm going to rewrite it with my y on the left hand side because that's a lot more familiar to me. And I'm now going to divide both sides by 10 to get y on its own. Remember that you're dividing everything by 10, so you're going to have 2 over 10x minus 15 over 10. That can be simplified, so I'm going to simplify it to 1 over 5x minus 3 over 2. That means that my second gradient, M2, is 1 over 5. So we're comparing m equals negative 5 and m equals 1/5. they're not parallel. If they were parallel, they would have to be the same. I'm going to check if they're perpendicular by multiplying together. I've got -5 times by 1/5, and that gives me -1. Keeping in mind that m1 times m2, so two gradients multiplied together, if they give us -1, that must mean that they're perpendicular. So for question 4, your answer is B, perpendicular. Question 5 gives us the vertices of triangle ABC, and it asks us to find the equation of the altitude from A. So over the last few weeks, you've learned about medians, altitudes and perpendicular bisectors. I would always recommend using a sketch to help you remember your steps. Remember your sketch, it is just a sketch. It doesn't have to be accurate. It doesn't have to be perfect. Just draw a rough triangle and then you can label your points any way you want. So there's my triangle there. The equation of my altitude is from A. From A means that it's starting at A and it's travelling down to meet the line BC. And altitude would reach BC at a 90-degree angle. So we can use the fact that we know that BC must be perpendicular to our altitude to help us find the gradient. So the gradient of BC is going to be y2 minus y1 over x2 minus x1. I'm looking at BC, so here's x, here's y, x and y, and I'm just going to call these 2 and these 1. So I've got y2, which is -8, take away y1, which is 4, over x2, which is 4, take away x1, which is -7. 8 take away 4 gives me -12. 4 take away -7, add them together, gets us 11. So the gradient of BC is -12 over 11. Now we know that the gradient of BC is perpendicular to the altitude from A. Perpendicular gradients, if you multiply them together, you're going to get a value of -1. But remember, the quick way to thinking about that is change the sign on your gradient and flip your fraction upside down. So -12 over 11 becomes positive 11 over 12. So we now know that our gradient is 11 over 12. Our A value is coming from A because we know that A lies on the line. So A is 2 and B is equal to 6. We can now substitute the points into y minus b equals m, x minus a, which is our new formula for finding the equation of a straight line at higher. So we've got y minus 6 equals 11 over 12, x minus 2. I'm going to get rid of that fraction by multiplying everything through by 12. That gives me 12y minus 72 equals, remember that when you do that, you're essentially just knocking that 12 off the bottom and you're multiplying this bracket through by 11, gives us 11x minus 22. Now that would be perfectly acceptable for your final answer, but remember we now know that our next step is going to involve simultaneous equations. Part C's of your straight line questions usually want you to find a point of intersection. So I always get into the habit of rewriting it in a more familiar format for simultaneous equations. So I would write that as 12y minus 11x equals 50. So my x's and y's on one side and then my numbers on their own on the other side. And that's my final answer. But like I say, either one of them, or even rewriting it in the form y equals mx plus c, that would be absolutely fine. Question 6 is the exact same triangle as question 5, but it's now asking us to find the equation of the altitude from B. So again, we're just going to do a rough sketch. This time I'm just going to label them A, B and C. I'm not going to bother putting my coordinates in, I'm just going to refer back to them. We're looking at the equation of the altitude from B. Altitude from B means it starts at B and goes straight down to meet AC at a 90-degree angle. So remember, when you're finding an equation, you need a point on the line. In this case, it's going to be the point B, and we need the gradient. So to find the gradient of that dotted line, again, we're going to start off by finding the gradient of AC and then use the fact that they're perpendicular to each other. So we've got y2 minus y1 over x2 minus x1. And we're looking at the coordinates A and C, so label them xy, xy. I'm going to call these points 2 because they're all positive, and these ones 1, but you could do that in any order. My y2 is 6, take away my y1, which is -8, over 2, take away 4, On the top, I've got that double negative, so I'm adding to get 14, and I get -2 on the bottom. So my gradient of AC is -7. We're looking for the perpendicular gradient to that, so remember if you multiply two gradients together and they're perpendicular, you would get -1. But the quick way for us to think about that is to change your sign and flip your fraction upside down. Now right now, -7 doesn't look like a fraction, but remember any number is just that number over 1. We just don't always write that it's over 1. So -7 over 1 becomes +1/7. So that is the gradient of our altitude. For the coordinates B, we can see that A is equal to -7 and B is equal to 4. We can then substitute this into y minus B equals x minus A. So we've got y minus 4 equals 1/7 x minus -7. I'm going to multiply through by 7 to get rid of that fraction. So we've got 7y minus 28 equals, now remember by multiplying through by 7, you're essentially getting rid of that 7. So I'm going to do 1 times that bracket, and I'm going to take account of my double negative to get x plus 7. That would be perfectly acceptable as a final answer, as we're rearranging it into the form y equals mx plus c. But again, because we're getting set up for solving simultaneous equations in our next step, I'm going to rearrange that to 7y minus x equals 35. So all my letters are on the left-hand side, and then I've got my numbers on the right-hand side. If you've got any questions about anything that I've went over, then obviously just get in touch, let us know how we can help.